We're going to pick up today with some rational roots, which are fractions as exponents, and we're going to do some higher powers. I believe we've got a cube root and a fourth root. So we're going to look at things other than square roots, but keep in mind the process for square roots. It's very similar. If you take a look at number 9, what I would suggest you do is rewrite this rational exponent as a root. We know that that means that's a cube root of x minus 4, and that value is being squared. Still equals 16. Easiest thing to do is to get rid of the roots first. We'll raise that then to the third power. I'm going to raise this side to the third power, and I have no idea off the top of my head what 16 cubed is, but I'm going to leave it as such. The cube root cancels with that cube, and so I get x minus 4, that value squared. Well, the way we get rid of a square is we take the square root. So I'm going to do that on both sides. Remember, that exponent can float out, so that's really the square root of 16 cubed. When I take the square root over here, because I introduced that root, I have to have absolute value of x minus 4. When I do that, I'm going to need a piecewise, and on the right hand side, I know the square root of 16 is 4, so this becomes 4 cubed, which, oh yeah, we know that, that's 64. Looking at this piecewise, we'll get x minus 4 if x is greater than or equal to 4, and the opposite of that if x is less than 4. So I'm going to have x minus 4 equals 64, so 1x possibly is 68, and negative x plus 4 equals 64, so negative x equals 60, x will equal negative 60. I need to check both of those solutions because it's not a guarantee that they work, so plugging back into either the original or perhaps the root form of that, I'll just plug in where I had the cube root of x, which I'm going to start with the 68, minus 4. That value gets squared, and it's supposed to equal 16. 68 minus 4 is 64. Cube root of 64 is 4, and 4 squared is indeed 16. So this one works. 68 is a solution. Plugging the other piece in, we'll get the cube root of negative 60 minus 4. Whatever that gives me is going to be squared. Supposed to equal 16. So that is a negative 64. If this were an even root, we would have a problem, but since it's a cube root, I can take the cube root of a negative. So that gives me a negative 4. And when I square a negative value, it still gives me a positive. So this one checks. Negative 60 should be an answer. On the next one, I would start out by dividing both sides by 2. Get rid of that 2. Because 2 is not raised to the 2/3 power, and you would be tempted to write the 2 underneath the cube root, but it is indeed outside of that. If we divide it, though, that's not a problem. So I can rewrite that as the cube root of x minus 6. That value squared is going to equal 100, and so we will cube both sides, canceling the root. So I get x minus 6 quantity squared. I don't know 100 cubed, but I'll just leave it as such. Take the square root, and we know that's going to give me x minus 6. It will be absolute value because we introduced the root. Square root of 100 is 10. 10 cubed, you're supposed to know, is 1,000. Piecewise here, x minus 6 if x is greater than or equal to 6. The opposite of that if x is less than 6. So we get x minus 6 equals 1,000. One good answer then is 1,006. The second value, negative x plus 6 equals 1,000. So that winds up being x equals a negative 994. Both of these answers check out. I'm going to show you my work here, and you can see how they actually check. But when you do that, you plug them both back in, and they do both work. Right? Moving on. Number 11, you're going to wind up with the exact same thing as square roots. You need them to both be on separate sides. Oops, let's get 11 here so you can see it. Sorry. To get rid of a cube root, I am going to cube all these pieces. So when I cube here, I know that just gives me 2 minus x, because those will cancel. When I cube over here, do be careful. You're going to cube the root, and you're going to cube that number. Right now that says 2 times the root. So when you cube everything, that'll say 8 times, and the inside of that's what's going to be left. So that's 10 minus 3x. Those values are equal. Distribute your 8 or divide both sides by 8. Really probably easier this time to distribute. And when we do so, right, I'm going to kind of skip through there just a little bit. I will wind up with x equals 78 over 23. Again, ugly answer. It's like 3.39 blah. You can plug that back in. I'm going to show you the work on that. It does check out. Right? So when we plug it back in, I did leave it in an unsimplified form. I've got a radical on the bottom. But as long as they match, that's okay. Yeah, take a look. You will be expected to check your answers. All right. So when we take a look at 12, this one now is 3/2 versus the 2/3 we had a moment ago. So looking at this one, when I rewrite that, that's a square root of x plus 1, all being cubed, 125. So I'm going to square both sides first to cancel my square root. I'll have x plus 1 cubed over here. Over here, I'm squaring that value, and I am writing 125 squared because we're not going to bother with a big number. We are doing these without a calculator. To get rid of a cube, you're going to do a cube root, and you're going to do that on both sides. That will cancel, and since it's cubed, we don't have to worry about absolute value. We just get x plus 1. The cube root of 125 is 5, and we're going to square that. So we get a 25. X winds up equaling 24 then. This value does check. You can plug that in, and here's the work to show that. All right. For these last two, 13 is a 4th root. The concept is exactly the same. I want my roots to be on opposite sides. Makes the work a little bit easier. So I just subtracted this front one over. The 4th root of 2x, I just subtracted that to the other side. So really I don't need the 0. And I'm going to raise both of those to the 4th power. 4th power cancels a 4th root. We would get x plus 3. It is an even power, so we do want to worry about absolute value. When I 4th a negative to any even power is going to be positive, and the root will cancel with the power, so we just get 2x. Looking at x plus 3 and negative x minus 3, greater than or equal to negative 3, less than negative 3. And so we'll have x plus 3 equals 2x. Well, that's x equals 3. We'll come back and check that. And negative x minus 3 is 2x, so we'll get 3x equals negative 3. We get a negative 1. We need to check both of these. When we do that, we're going to have, to check this one, we're going to have the 4th root of 2 times 3 plus the 4th root of 3 plus 3, and that's supposed to equal 0. Okay, first of all, these are both going to be positive values. You can't take a negative out of a 4th root. I know this is not going to equal 0 because I'm adding a positive to a positive. That will wind up being 6 inside of each of those, so I could say it's 2 fourth root of 6. Definitely doesn't equal 0. Over here, I'm going to do the same thing. That'll be the fourth root of 2 times negative 1 plus the fourth root of negative 1 plus 3. It's supposed to equal 0. So that'll be the fourth root of a negative 2. We're looking at a complex or imaginary piece here because I can't have a negative inside of an even root. Over here, that's going to be the fourth root of a positive 2. I do not add the radicands. Those cannot cancel. Even though I see a negative 2 and a positive 2, they're both inside of radicals, so we are stuck. That is not going to equal 0. Last problem. This time we've got different fractions. They are not both halves or both fourths. The easiest thing to do with this is to find a common denominator. It's kind of like when we were putting them all underneath one radical. So I'm going to rewrite that to be 2 fourths. So that'll be the fourth root of 2x plus 1 squared minus the fourth root of 3x plus 4. I'm going to add the 3x plus 4 over, so that'll actually equal the fourth root of 3x plus 4. And since these are both fourth roots, I'll go fourth power on both sides. So I will get 2x plus 1 quantity squared. Over here though, I just get 3x plus 4. I am going to have to multiply those out. When I do that, that's going to give me 4x squared plus 4x plus 1. 3x plus 4 is the right side still. When I subtract that over, that's 4x squared plus x minus 3. Always good to try to factor. This one does indeed factor. Look at my signs. I know that's our setup. I believe that's plus, so I get a positive 4 minus 3. And x winds up being 3 fourths. And x winds up being a negative 1. We do want to check those. That will be the fourth root of 2 times 3 fourths plus 1 value squared minus the fourth root of 3 times 3 fourths plus 4. It's supposed to get 0. When we do that, that's 6 fourths or as you finish solving those, you'll see that when you plug 3/4 in, you wind up subtracting things that are not the same, so they won't equal 0. Same thing kind of happens when you plug -1 in. You actually wind up getting a complex on the first piece, and you should subtract that from 1. That's not going to work. So in that case, it's also not going to equal 0. So your answer is no solution. You can use the empty set, or you can actually write out no solution. Right, thanks.